Thanks everybody for coming. What we want to talk to you about today is API automation testing. One of the things that we found at Rackspace, because we use Python and we're always building APIs, there's not a one-shot tool that you can use to do everything. When we use third-party tools, we always find out there are thousands of false positives, and nothing's worse as a developer. You come up and you say, hey, I need to fix these 700 bugs. Well, like 680 of those are false positives. So Michael and Nathan have worked very hard over the past several months, going back, probably back to spring when we presented in OpenStack our API automation. We already did the introductions. Little picture of kind of what each of us like to consider ourselves. Brad, a little bit about Michael. He went to the Grand Canyon and
Solano in August.
So he did a good job there. So let's talk a little bit about security engineering and what that means to Rackspace. In Rackspace, quality has the job of making sure that there's three pillars. We want to make sure when we build a product that it functions. We want to make sure it works. We want to make sure it performs well. But we also want to make sure that it's secure. So for our statement purposes, we fall under the quality engineering umbrella. We call it QE because a lot of our quality and security folks are developers. They just happen to be very good testers as well. So a lot of our strengths come from development and quality, and of course testing. As you see up there, we have the same kind of job as quality, but we do break it down into the performance side of the house, security and quality. The reason we do that is we want to specialize. When we have a developer or a team build a product, we want to make sure it goes through rigorous testing as part of the SLDC, software lifecycle. As we look at testing, we all look at the same ways to set up, execute, and interpret the results. What we found is this kind of setup works a lot better than having security sit somewhere else when you're in the software dev. The reason being is these guys sit with the developers and help develop as well. So instead of waiting for the code to be ready until 2 weeks before deployment, we're actually there during the whole process. That means from design. And you got Kevin Williams, who did a presentation earlier, sitting back there. He's our architect. And, he's the first person on scene when some of the architects start looking at design and application design. When we did a presentation back in May at OpenStack Atlanta, anybody able to attend that? No. I encourage you guys to go to the OpenStack conference. It's very well informed. What we did there was our first presentation on the API test automation. As I said earlier, the challenge that we have at Rackspace is there's no tool that does everything. A lot of our development is in Python, so if some of you testers, especially security testers, know that there is not a Python static tool analysis. So what we have to do is we have to actually build our own. If we can't do that, then we're doing a lot of manual testing, which is one of the reasons why they have to be developers. I'm going to go ahead and turn it over to Nathan, who's going to talk a little bit about what he's developed and how he got it.
So I'm going to talk a little bit about OpenStack first. What OpenStack is, it's free open source cloud software. All it does is manage your infrastructure, essentially. OpenStack also includes, I don't know if any of you are familiar with all of these APIs, but CVS is block storage, that's virtual hard drives, compute is virtual computers, database, virtual databases, identity is authentication, images is if you want to store your OSs, you store them in clients, which is images, networking, virtual networking, object storage, hosting files on a web server that you can link back to your web pages. So if your web node doesn't have a terabyte of storage space, you can store it in object storage. Orchestration, that's the deployments. If you want to spin up servers that already have something completely installed and set up, and the orchestration can be multiple servers, kind of like all your big data Hadoop. You could have a deployment that deploys several nodes instead of just one server spinning up at a time. And telemetry, I forgot what that is. Sorry, that one's new. Anyway, lots of companies use OpenStack. Here's just a list of them. If you need more information, openstack.com. Next one. This is this is a little bit of architecture of OpenStack. I'm not going to go into details, but just some small pieces. Keystone, which is identity. Everyone is touching that because everyone has a token that they validate in order to access the resources, and it's just showing you how they use dependent. They're dependent on each other. Glance, which is the images, actually uses files to store its images. So it's just a very interdependent system. Next slide. Okay, so now on to our quality engineering organization. These are our trifecta. Essentially, we have our performance, our quality engineers like myself, and our security engineers as well. And this is our program. Okay, so what I was working on, I originally started on the security team, and I worked for Jim, and we did a lot of manual testing, and we started doing some automated testing, but we really didn't have a good grasp on really automating tests like the QE department did. So they built this framework, and I helped build it, called OpenCafe. And what OpenCafe is, it's an open source testing framework. It's not actually tied to OpenStack. It can test anything. That's one of the benefits that I like about OpenCafe versus Tempest to OpenStack test framework. You can put OpenStack in your cloud, and you can run the Tempest test against it, or against the dev stack, but you can't test your building infrastructure that maybe you wrote plugins and integrated with OpenStack usage. And that was a big deficiency for Rackspace because we have so much integration into our identity. We support all kinds of authentication that OpenStack doesn't, and it was just very hard to test with the OpenStack test framework. So that's why we created OpenCafe in the first place. That'll work. It's fine. So this is the architecture of OpenCafe. It's all about abstractions. You use abstractions to make your life simpler, right? Because you don't want a standard test case to be 1,000 lines, and then you hand this code off to someone else, and they're completely confused, right? They have no idea. Your test just looks like it's doing hundreds of things, when really it's a simple test like create a server, cat a file off of it, and see if that file contains X. So this is our abstractions in OpenCafe. We have our models, which handle serialization and deserialization. They're essentially just objects that can convert your request to XML or convert your request to JSON or any other format that your API uses. Then we have our clients. Our clients is what we pass our models into, and they normally are tied to single calls, one API call. You don't want a client that you make one call and it's actually hitting 3 APIs and doing very complicated things. And then we have our behaviors, which is our business logic. Our business logic is where we do the scenarios, the create a server, wait for it to be created, and then kick back the server details. And then our tests, which utilize all three to test any given scenario. So instead of tons of code, you'll have a behavior that's like create a server, wait for it to be created, and then attach a block storage, for instance. So that would just be a 2-line test, and then you would check the results. Did the attach happen successfully? Assert this. Okay, next slide. Okay, on top of those abstractions for building the tests, OpenCafe is split into different, or not OpenCafe, but OpenCafe is designed to be used by several different cafes, essentially. So OpenCafe is the engine. It contains all of your base models, base clients. It has a plugin architecture if you would like to add more base clients. For instance, you need to connect to your MongoDB. It's not a standard, it doesn't come with OpenCafe. So you write a plugin for it, and now all your client. Now you can write a client that connects to your Mongo database. Our base behaviors, it's just a class that adds logging. It doesn't really add much features. So a lot of the base is just for logging. We have several runners, and the reason these are all together is because that's a very runner. All of those are runner specific. Data generated tests, like unit test, for instance, doesn't have data generated tests, but some of the behave, I believe, might. And we normally use our unit test runner, which we have modified significantly to add more of a functional test framework than just a unit test framework. And then, of course, configs. Now, Cloud Cafe is where, and this is if you're testing OpenStack, is where we push, and you have one of these for every group of products. Like we have a building cafe inside of Rackspace. It's not public, but Cloud Cafe is public, and you can actually find that on StackForge, if github.com/StackForge, if you're interested in looking at some of the code. But Cloud Cafe contains all of our product models. So to create a server, it requires these attributes, and we have that model in there. And then it kicks back a response. We have a response model that will change it into an object from XML or JSON. And then our clients, they pretty much map exactly to the OpenStack docs and our behaviors. And the behaviors is where the most complicated code lives. It's where if we needed a test to do X, Y, Z, this is where we start writing behaviors to abstract that. So, and then the roast, and we named all of these after coffee because we drank a lot of coffee when we were coming up with this. So, and our roast contains all of our tests, and that's pretty. So one roast doesn't have to just use one cafe. Our billing infrastructure roast uses Cloud Cafe, the billing cafe, the Atom Hopper cafe, just several different cafes, because we have such a wide infrastructure and we build everything. So next slide. Okay, so what's the main reason we switched? Flexibility, as well as having everyone on one framework, allows us to take a QE person from servers and put them in files, and they instantly spun up. They're like, oh, you're still using models? That's exactly how we do it over there. And so the flexibility with the plugins. I wanted to point this out, that again, reiterate, it's not tied to OpenStack. So if you want to do large integration testing of your cloud with billing with some other system that's not related to OpenStack, it's easily done. Plugins can be written for any type of runner. I'm not a fan of Behave, but a lot of people want their tests in standard English, so they like to use that runner instead. And it's easily integrated with Jenkins and other CI tools. Oh, next one. Okay, the security logo. Now we get to the security cafe, and this is a plugin that we've written for OpenCafe. The security cafe is basically, since it's not a standard cafe, it doesn't have API. There's not a security API that we're testing, so it doesn't really have clients. It has mostly behaviors and data generators. So what we can do, and some of the things that we've written in this are like a model fuzzer. We pass in our object model, and it will recursively iterate through the model and submodels and generate payloads that contain a fuzz string in different places in our model. So it allows us to leverage the QE work, because they've already built all these models for all the products. So the security team can leverage the work they've done, and they don't have to know what the API looks like. They can just pass in a model, and then it will fuzz the entire thing, every field. We have another one that injects XXE. Just any security test that you can think of, we just add them, and we try to add them as generically as possible. So if you write something to test this one product, we want it to be able to use it again to test another product. So This just goes over a few: authentication, authorization, and secure transport layer, denial of service, and hidden functions. We've actually started having the security guys write the tests, and they've actually started putting them in the QE guys' Jenkins. So now, if a test fails, it's not on them, our small security team, to monitor the 100 projects at Rackspace for every bug. It'll now fall to the QE team to say, oh, why did this test fail? We need, and then raise the issue. Because for security, a lot of times, you have a small team trying to encompass an entire organization. So, I don't know, anyone else have that problem? Or everyone has plenty of security engineers? Next slide. Okay, so advantages of Security Cafe, reuse, identifying security defects when you're fuzzing, there's most of the stuff that we've talked about already. Let's see, what did I not hit? Oh, the different environments is very, very useful with the cafe. We change one config, we run it on DFW, we change one parameter, now we're running on ORD. One more parameter, now we're running in Hong Kong. So the way our API, our configs are done in cafe, we can just swap them out. When we're running it as command line utility, we can just type in a different config. ORD, JSON, .config.
Where's it?
Chicago. ORD? ORD is our data center in Chicago. Okay, next slide. Okay, so data generated testing. This is very, very paramount in security, because fuzzing can be very difficult if you're doing it manually for several different products, several different APIs. So this is an example of our data generators. We have a base model data generator that will take in a model, and it will take in a model in it, and then we just extend it and we give it the strings that we want to fuzz in that model. So in these two cases, we're opening an SQL injection file that contains all these SQL injects, and then here we're opening a set of all Unicode characters, and then we can append these two classes on any one of our tests, and it will pass in that model serialized into the format that we want with those fuzz strings, several million in case of the Unicode one. So we'll have that many test cases with that model. So it's not just the string we're passing in, it's the actual request fuzzed with the string in all the fields. So if we have 10,000 Unicode and the model contains 5 variables, we'll have 50,000 tests. So anyway, next slide. Okay, so this is one of our SQL injection tests. This is what it looks like when we write the test. So the abstractions play a big role here. So we said at the top that we're tagging it so we can reference that type of test with that decorator. Next, we are saying that this is a data-driven test, and we're passing that SQL injection data generator with the request model for this test. And what the test is doing is creating a network, and this is using, for our developers that use requests, this is using request, which is an HTTP client, and it is sending in data as string. Well, data and request is the body. So this data generator is passing in the string, and then it's sending it in the body of the create request. So we check and see if the network is created and the string, was, a name and didn't really do anything, then we'll delete the network. And then we have this SQL error handler that checks for odd, stuff that's not 403 or 200. It'll be like, 500, some other error some other status that we don't even know, or the body will contain just completely nonsensical information. So that's another method that we wrote that's not on here, not on the page. Next slide. All right, this is some more of our test cases, authorization test cases. Oh, that last, go back to the last slide, one more thing. This test actually runs about 10,000 different API calls, just as a side note. So, okay. And then these are our more non-fuzzing, just normal, we need to test this. So this is a standard test, it's not a data generated test. And what we have a client one doing a get networks of a different get network of a different client's created network. So it's just testing role-based access and that kind of thing. It's very easy. The abstractions allow us to do it in one line and then assert that, it failed. So, and all of these are pretty much similar. Next slide.
So let's talk about this. So when we first started in product security, we kind of all testing manual. So it's traditional we do it. The first, we ask the team for test count, endpoints, and then we read the documentation. And then we're trying to use Python script or use curl or use Burp, trying to make successful code. And we found out it took a long time because we are a small team and we jump among the different products. And we found more than one time all those documentation are not accurate. So we copy the JSON request and throw it in our Python script and turn out it did not work. So we have to go to talk with the QE, talk with the oh, we updated that, but we forgot to update the documentation. So it happens more than a lot of time, and it's really slow. And after that, if we are lucky enough to bypass that stage, at the next stage we just use a Burp intruder to find all the function calls for all the data elements. After that part is done, if we saw something interesting, something was figuring wrong, we do some manual testing, just use Burp or use a SQLMap or other tools to do different types of security testing. This involves different injection, authorization, hidden function, delay of service, stuff like that. After we are done with this, we hate to do this, but we have to report all the findings to the developer team and to our manager and send it to the team, and then we wait. If they fix that, they send us updates. We go there, redo it again, especially for the verification part. So verify that it's fixed. If it's fixed, we close in our defect system and move on. If 2 days later, the developer says, okay, we just update another feature. I want you guys to rerun your test again. Oh gosh. So it started the whole process almost again. The only thing that we can skip maybe the first 3 steps, but we need to fill in all the stuff again. Especially depends on which part they change. If they change the library that's used by, by the product, we have to rerun this again. Next slide. So here are some challenges for our audit process. And you can see it's manual and it's not efficient. And it's very difficult to repeat, just like the business audit. If we have one endpoint in Hong Kong, another endpoint in DFW, another in Chicago, we have to run 3 tests. And it's extremely difficult. And we have engineers that come from different backgrounds, and some have pretty good knowledge about the testing. Some are new guys, and their technical skill is kind of different. So you can see dramatically different results from the tests they have. So that's another of our concern, because different engineers give us different test results, even if they are testing the same products. And the knowledge sharing is the key here, because people sometimes got sick, people leave, if Nathan is testing his product and he left, and another new guy come on, he has to go through the whole process. It's called time delay for the project. And as more and more our products move to Agile development and do CI/CD, we said no, there's no way for us to do CI/CD. We asked, 2 weeks or 3 weeks to do a full round of testing. If you want to release another major release, we need 2 weeks. I said, no, it's impossible because we release, 3 or times each day. I said, okay. We just pretend everything's okay. So, can I go next slide? So we are working on this new process, so we want to do automation. And we saw our KOE success story because our KOE testing is automatic. And we also realized we are a small team, we have hundreds of QE, we have only 10 security guys, and we need the help from our QE folks. So we came up with this new process. They work on the security cafe and the cloud cafe, open cafe stuff. We did some test drive and found it's exactly what we want. So the new process is, the first step is always the same. If we test the product, we got our test counting the points. But we work close with our QE guys because they have been working on the product for a long time, so they know a lot of knowledge about those products. So we have a knowledge sharing session with them, so we can learn better about products. If we don't know the product, it's very difficult for us to run security testing here. But because QE is using Cloud Cafe and we are also using Cloud Cafe, so we can reuse a lot of code they create. Just like Nathan said, if the QE already created the module, create the request, the response, we just reuse them and we can plug in our stuff and run our test quickly. After we do that, let's say usually create some test strategy, so that we can show our manager what we are trying to do, what type of test we are going to run. And we can leverage the security cafe to do a quick flooding to our API code, so we don't rely on the Burp intruder to do our stuff. Even you have to click a few buttons to do the flooding. But if you think about if you want to flood 100 function calls and you have to click the button 100 times, that's really not good. Next slide. So after we flooded, we got the results back. We delve in depth testing about what we are trying to test here. So for example, we talk about different injection testing and other stuff. We can leverage Burp and some other tools because it's almost impossible to, at this stage, for us to have a fully function point and shoot API scanner. So there definitely involves some intelligence, especially if some tests are related with the product. For example, if you want to test the neutral network, you need to create the network first, and then you need to create subnet, and then you need to create a port. And then you need to connect the port to the server we spin up. So without manually go through some of those stuff, it's very difficult to see where the potential security defects could occur. So we spend a lot of time on those complex scenario security testing. And after we finish that, if we found any defects, or even if our test did not find any defects, we spend some time creating test case to cover all the tests that we already run. So our philosophy is for every test we run, whether we found any security defect or not, we're going to create a test case within our framework. And by doing this, if Nathan leaves for vacation, go to Hawaii for 2 days, and I jump in, I just use get git code from GitHub and just run our test case. I know what is that. After that, another key here is because the QE engineers have been working closely with the development team, and they are already embedded in our CI/CD. So once we create our test case, we just share with our QE folks, and they can run with their CI/CD process. So it makes it possible for us to embed our security testing with our CI/CD.
Excellent.
So during the whole process, we noticed that it's very important for to us working together, especially security engineering and the QE engineering. We have more than one case where QE engineer found security defects and they reported to us. And during our testing, we also found function defects, and we send the notes to them, and they can add all those into their test cases. By working together, we are building a win-win situation. So we short our test time window, and we found more defects, and we improve the security level of our products. Next slide. So we're going to talk about some common issues that we found for OpenStack. So we did test quite a few OpenStack projects. We have not finished them all because there are so many OpenStack projects. But during this process, we saw a lot of recur patterns. That's really scary, so I want to share a couple with you guys. I cannot share all the details, but I can share some of it. One of the big stick points is their input validation is very inconsistent, and you can definitely tell, those codes are written by different developers. So for some of the projects, there's low use input validation at all. So they just blindly accept anything. So for your name, you can put whatever you want. You can throw one mag, question mark, they have to accept that. And for some of the projects they are trying to use blacklist approach to do their validation. They are just trying to find out the special character and reject those. For some projects, they did a decent job trying to use whitelist approach to accept the good results. But you might notice, they only check the type, they did not check the length, they only check the format, and they missed some other parts. And the second big thing is error handling is very inconsistent, and you can see stack trace almost all the time. And it's very hard to get to 500 with stack trace. We always joke, whenever we run our test case, a suite of test cases, you're going to see hundreds or even thousands of 500 with all those stack trace. All those are, interesting, especially for security guys. Because 500 normally means the application error. The application cannot handle the input. It's always worth to dig a little bit further, and you might find, you can kill one API load just with one request or something like that. And the last thing I want to talk about is there's no protection against automation attack, so they don't do written image and they don't do lockout. So you can just keep sending the request within one token, again. So it makes us happy. One of the common scheme we use to lock down our OpenStack API loads, we call it pump dump. So basically, we just send a request to create entries within the database. After we create maybe thousands of entries within the database, we just send the GET request. When the GET request hits the API node is trying to pull all the data entries. Because there are thousands of entries there, the payload might be more than 5 megabytes or something like that, and the database just cannot handle that and die. We call it a pump dump attack, and we found a lot of API loads subject to this attack. Okay, here is one real example for the heap stack creation. So heap stack is a project that you can create your in this case, we are going to create a WordPress site. So you can specify how many servers you want, what's the database, what's the load balancer. If you create a stack, the the API load is going to try to spin up all the server for you, and they're going to create a database, do stuff. And during the test, we found for this request, for DB host, if we send a huge string, more than 1 megabyte here, we're going to see some interesting response back. Next slide. So this response come back, and we said there are stack traces with a lot of stuff here. For this one, it's kind of unique, is because once we saw this, we are trying to send more requests. And we found out now, even if we send a normal request, we cannot get any response back. Everything, no matter whether it's malicious or good request, always return 500. So we report this to OpenStack, and they did some digging. Next slide. And we found out that one request killed the API nodes. Because in their database, they have maximum length for all the data elements. For the DB host, it's that side. Anything bigger than that will be trunks. And when the API load is trying to be on the back end, they get all the elements from the request. They build a huge JSON, and then they try to pass that JSON to their templates to decide, how many servers you're going to spin up. And in the original design, they are trying to validate all the stack. So even if one stack was trunk, and it's invalid, it just keep trying to validate, So it's just a dead loop. And in the end, it just kills the engine. I go to the next one. So this one is a storage cross-site scripting issue for Horizon. Horizon is the control panel for OpenStack. So instead of using the API, you can also log into the control panel, and you can spin up server, create network, do a lot of stuff. We found this when we run our API filing, and we log into Horizon, and then check, oh, holy cow, they just pop up everywhere. What happened? And we a little bit bigger and found that there is no validation for email, so we just inject a lot of JavaScript through email. And therefore, they did not do a good job of outputting encoding. Let's talk about what our plan for next stage. So we are trying to add more test cases for different products, but because OpenStack have a huge list of products, it might take a while. And we are trying to improve our security cafe. We are trying to let the cafe become a little bit smart, that it can find some simple defect by itself without us to write some code. And for some test case, we want to automatically generate some test case. And we want to track the security defects over time. Next slide. And we also want to open source this security cafe, because Rackspace can be a huge supporter for open source. We believe in open source. We want to help the community, and we also want the community to help us. Next, we're going to some demonstration. Do we still have time? We have 5 minutes. Hope the demo go is good with us today. So, can you all see this, or is it too small? It is better. So for this one, we are trying to test the Keystone project within OpenStack, and you can say identity is our name for the Keystone. For the dev.json, that's what we call the configuration file. Within the configuration file, we see where the endpoint is and where the username, the credentials. For this one, we want to do some following. So if we call, so that is tag. So we use tag to define different types of tests we want. So it has tag to SQL injection, tag for authorization, tag for the filing, different stuff. So when it runs, it just goes through all our data-driven stuff and trying to send the request to the endpoint and analyze the response to see whether it's defect or not. We can use Burp Proxy here to see what the request we send here. And you can see the first request is authentication. Basically, the framework can go there, talk with the system and try and get a token, and it just start flooding around. Okay, so for here, it's just flooding. So it's trying to inject something with the password, stuff like this. So it just keep running, like soldiers. Sorry, like Nathan said, for this flooding, it's going to generate hundreds of requests. Let's stop this. Let's run a SQL injection. And the framework is going to save all the requests, the response within a log file here. So it's very useful because we use it to save our Burp request and response to show, audit team that we did our test. And by doing this, there's no need for us to do that because everything has already been saved there. So we know they are there. So for the SQL injection, so you saw one of the test cases failed. If we go back here. Yeah, the first one failed. If you go here and you can see the response is here because you can see they retain the SQL statement within their error message here. So because in our error checking, we are checking for this type of message. So by default, a bad security practice should never retain your SQL statements in the error message. So that's why you see it failed, and we mark on the defect. They should address this. Okay. We have more stuff to show, but we run out of time. If you are interested, you can come here. We can show you what we have and we don't. If you guys have any question.
Yeah, if you have any questions, we're going to open up the Q&A.
So the security cafe piece is not available yet, open source?
Yes, it's not open source as of now. It's on our internal.
Do you have a timeline for when it'll be available?
I don't know. I think that goes through like the people that approve our open source projects.
I would say about probably 60 days from now.
Oh,
Yeah.
With all the security testing that you do, from functional, performance, capacity, and security testing, how much would you say security, what percentage of that is security testing?
There are a much greater number of QE functional tests than security tests, just because of the size of the organization. Yeah, 10 people trying to do security tests for all of the product versus, a team of 200.
But what, of all the tests that you run, what percentage of that is security testing? Is it 10% of testing, 20%?
Every product at Rackspace goes through security testing.
Right.
So if you look at what my team does, everything, it's 100%. Nathan is in the development side. He actually writes the tools for us. So,
Yeah.
did that answer your question?
No.
I want to know the number of tests.
It's much less, because while they're security testing a product, they have, unless it gets integrated into the CI process, their test will only be ran when they're testing the product.
Now, what I'm trying to figure out is if you have 1,000 tests that you run, of those 1,000 tests, how many of those would you say on average are security-related tests? How much time should I spend doing security testing?
It's different per product at Rackspace. It's very dependent on the team. A team like Barbican, who's basically doing a security product, they have a large amount of security tests. Identity has a large amount of security tests. But as far as the QE goes, take block storage. There's the standard smoke tests that get run are about 400 tests. And most of them are functional. By and large, most are functional. There's very, very few that are security, because all the different combinations of, okay, I'm going to spin up a Windows server, attach a volume, detach a volume, to, there's just so many combinations. Linux server, they have to then, by and large, the majority are just functional testing. So it depends on the product.
A perfect example is we have a guy that's sitting with our containers team, and he's actually helping us build test cases on a daily basis, and he's 100% dedicated. So in that sense, that individual on my team is testing 100% with QE. So they're matching test for test. Go down a product that's maybe not as critical or not as profitable, it's a lot less. So it really depends on the product.
Okay, thank you.
But actually, the short answer, whatever you're doing, it's probably better to do more.
You have a question?
It's great, of course, to have this great level of automation that you have and all this, but the question is, your team is not really in business of creating security scanners, and you cannot complete this commercial scanners like that scan, Hailstorm, even Proxy. It's not like for, competency. So the question is, aren't you afraid that like you can, your test will not be that comprehensive as like commercial scanners?
We're kind of testing different things. Burp Suite.
If you take a look at like what you are testing, it's
Well,
exactly the same
okay.
what like security scanners.
Fuzzing, sure. Actually, we take a lot of our lists that we fuzz from other tools, like the FuzzDB, is what we're passing into the SQL injection that we're running. As far as iterating over our APIs, I think that our tool does that better than a tool like AppScan. Because AppScan doesn't really know the syntax of our API calls, so we essentially have to do one at a time,
Yeah, but I consider this like scanners like AppScan that has been like on market for years as kind of like legacy knowledge base. So you can like address some contemporary threats that you are aware of, but you can easily skip something that has been tested in the past and you apparently don't have.
So for this one, this tool is designed and used by both, used by security engineer and by the QE engineer. So when we do our flooding, that's not the test case that QE is running, right? For flooding, it's mainly flood a huge amount of stuff, and then we can lock down certain area that might be the problem. So that part is a much smaller flooding site that we don't send it to our QE team. So for example, the example I show here, if we count all the flooding stuff, that's 50,000 test cases. But when we send to the QE, definitely no. So it's a much smaller sample of what we are doing here. But it should be able to cover all the stuff we did. So for example, for the flooding DB, we might choose 1 or 2 or 3, that's key. And we are 100% sure by testing this, it shows that we allow stuff into SQL injection. And give those to the QE folks, inviting into the security testing for SQL injection. So for QE, all the test cases, they don't have no flooding test. They only have SQL injection or different type of testing. Flooding is just used by security engineering because we want to find more and more stuff.
Also, we normally only use this on backend. We don't use this on front end. And that's where I think AppScan would excel. Web pages, we don't use this on web pages. We would use so we have a different framework for UIs it's based off Selenium that we do all of our web page testing with. So I can't really speak about getting the same function.
Yeah, that's another project we are working on.
Like you are confident in what you are doing and you think that you can do better than others.
Yeah,
That's what I hear.
They can because they're testing their own APIs.
I haven't seen AppScan have the ability to testing your APIs. I mean, does anyone?
No, I think in general, that experience with AppScan might be expecting where their weakest is testing your own REST APIs. You just can't have a generic tool. by pedigree, those tools were built for web applications, and they're essentially built over the last 10 or 12 years. But really, the development in REST APIs and the way that you build and design your own APIs is very drastically different than a pedigree of web applications or websites over the last 10 or 15 years.
So it's like, they're claiming that they do have integration with hot-HTML APIs as well. So, for example, Burp Suite can be integrated with like FastDB taken from Google, right? So they can do that as well.
But you still have to, you've got to really train it to go deeper into your APIs. Right?
So,
You do it at your level.
just to give you an idea, we had them come down at Rackspace and we sat down with them and showed our pain points. And they could not give us what we needed, so that's why we ended up doing this. So that was the end.
And we had a similar experience. So we used some commercial tools for UI testing, but we couldn't use anything for REST. So we had to build something ourselves.
Yeah, this is a challenging question because our products behave differently. So you must learn the product to make it work. So for example, when we talk about the neutron network, it took multiple steps just to create a light work. So how are you gonna, let AppScan just do it? It is unrealistic.